This video is going to show you how to run a Spearman's non-parametric correlation in SPSS, as well as how you'd write it up in APA format. The experiment this is based on is relatively straightforward. What we did in this experiment, we gave participants a chili, which they had to eat, and then they rated it on its heat on a 1 to 7 scale, and then we measured the milliliters of tears that they cried after consuming this chili. If we look at the variable view, you can see we've got chili heat, and this is measured as an ordinal measure. This is because it's self-reported on a 1 to 7 Likert type scale. If you look at our measures, you can see we score them from 1 mild, somewhat hot, moderately hot, hot, very hot, why would you eat this, to I'll never taste again. So we can see participants had to rate how hot they thought that chili was. And then we've got milliliters of tears, and this is scale because this is a continuous measure. It's ratio data because obviously you can't have minus tears cried, you'd suck tears up through your eyes. But it is also notable that this data does not have a normal distribution either. If you'd wanted to do a parametric correlation, the data must be continuous and it must have a normal distribution. Chili heat alone being ordinal means you should really be running a Spearman's correlation on the data, though you'll see in the literature lots of examples where this type of data is correlated using a Pearson's correlation. This is very common to see. However, in this case, neither of the variables meet the assumptions for doing a Pearson's because chili heat is ordinal and milliliters of tears has a very, very large positive skew to it. We want to look at the correlation between chili heat and milliliters of tears cried. To do this, we go to our Analyze, Correlate and Bivariate, and this gives us our correlation window. This is exactly the same correlation window you'll see for a Pearson's correlation. We've got our two measures in the data set here. We want to correlate them, so we just click them across into variables. Now it's default set to Pearson. You see these two other options here, Kendall's tau, which I'll cover in another video, and Pearson's is already covered in another video as well. And what we want to do today though is we want to look at a Spearman's correlation. You can ask for multiple correlations, but really you should already know what type of correlation you want before you run your analysis. In this case we need to do a Spearman's correlation. We can either test the significance as two-tailed. There's many arguments in the literature about whether one-tailed or two-tailed testing is appropriate. What we're going to use, avoiding any of those arguments whatsoever, we're going to be on the side of caution. We're going to stick with the two-tailed significance. If you ask for one-tailed, essentially what it's going to be, the p-value for one-tailed is half the size of the p-value for a two-tailed significance. We can leave tick flag significant correlations. This will simply put stars next to the statistically significant correlations. And that's all we really need to do for a bivariate correlation here, and then we just click OK, and this will give us our Spearman's correlation output. It's labelled as Spearman's row here, so you know what type of non-parametric correlation it is. And you'll see what we've got is we've got a sort of 2x2 correlation matrix here with chili heat, milliliters of tears, and chili heat, milliliters of tears appearing again. You'll see we've got correlation coefficients of 1 here. That's simply because it's chili heat correlated with chili heat, and milliliters of tears correlated with milliliters of tears. And if you correlate something with itself, it's always going to be a perfect correlation of 1, and it's completely irrelevant and we completely ignore this. What we are interested in is the correlation between chili heat and milliliters of tears cried. And we've got 3 numbers appear in the table. The first one is our Spearman's row, so this is our correlation coefficient. As you can see, it is 0.862. The next line is sig, which is basically our p-value, and we've got a highly statistically significant association between the two variables here. And n is simply the number of participants in our sample. We'd write this up like this, and as you can see we report our correlation coefficients to 2 decimal places. In differential statistics as general rule we report them to 2 decimal places. The value in the brackets is simply n minus 2, so number of participants minus 2, so in this case 38. And then finally we write up our p value here. Because SPSS has reported 0.000, we write this as p is less than 0.001. If it gives you any other number, so if a number appears at any point in this, you'd write p equals. In this case, we don't have an exact p value because the p value, if you were to calculate it exactly, would be less than the 3 decimal places here, so it would be 0.000 something. In that case, we just write p less than 001, and we'd report it like this. So you can see that there's a significant positive correlation between participants' ratings of chili heat and tears cried after eating them. We know this is a positive correlation because the correlation coefficient is a positive number. Correlation coefficients can range between -1 and +1. If you get a minus, that means you've got a negative correlation, as in one of the variables goes up, the other one goes down, and I will show you an example of this now. This is just an expansion of the data. So these two columns are exactly the same, but now we've got chilies on pizza, and after they ate the chili and we tested how many tears they cried, we asked them to make a pizza and put the number of chili slices, not whole chilies because some of these numbers would be a bit ridiculous, the number of chili slices that they would be happy to put on their pizza. If you want to look at the correlation between chili heat and the number of chilies that they were willing to put on the pizza, we go analyze bivariate correlation. We'll just click them all across. So we want Spearman's again, we don't want the Pearson's, we leave it as two-tailed. So then we click on OK, and as you can see, we've got a larger correlation matrix now because it's now 3 by 3. So we've got 9 possible cells, we've got chili heat, millilitres of tears, and now the number of chilies on the pizza, and that repeats across the top. Again, like before, the diagonal in this table is always 1, doesn't have a p-value, and this is again merely the variable correlated with itself and is totally irrelevant. We'll see the other things now. We've got chili heat correlated with millilitres of tears, chili heat correlated with chilies on the pizza, millilitres of tears correlated with chilies on the pizza. And you'll notice that these are an exact mirror of each other. The table's doing everything twice. Millilitres of tears correlated with chili heat correlated with millilitres of tears. It's exactly the same thing, so we only really need to look at this portion of the table because this is just a repeat and this is totally irrelevant, so we only need to look at this half here. What do we see with this? Well, now if we look at chili heat and the number of chilies participants put on the pizza, you can see in this case now we have a negative correlation. The hotter the chilies were, the fewer slices they were putting on their pizza. So as heat goes up, chilies put on the pizza goes down. I'm going to write this up accordingly. There was a significant negative correlation between participant ratings of chili heat and the number of chili pieces they put on the pizza. And you can also see, because it's a matrix, it's correlated everything with everything, millilitres of tears also has a negative correlation with the number of chili pieces people are putting on the pizza, and we'd write this up also. In a similar way, there's also a significant negative correlation between the number of chili pieces participants put on their pizza and the amount of tears that they cried. And you'll note in this case we give the exact p-value of p equals 0.005. That's because we've got the exact number here. In both these cases we don't have the exact number, so we write p less than 0.001. So hopefully this has given you enough knowledge now to be able to happily run some Spearman's correlations and be able to report them in an APA format.